Hi, I am Kavitha, Assistant Professor, Department of Mathematics, Dr. SNS Rajlakshmi College of Arts and Science. Today, we are going to see a case study problem in probability. First, you have to know about what is probability. Probability means possibility. It is a branch of mathematics that deals with the occurrence of a random event. The value is expressed from 0 to 1. Probability has been introduced in maths to predict how likely events are to happen. Now we are going to see the problem. A coach is training 3 players. He observes that the player A can hit a target 4 times in 5 shots. Player B can hit a target 3 times in 4 shots. Player C can hit a target 2 times in 3 shots. Let the target is hit by what will be the probability that A, B, C all will hit. Here we develop the independent event activities. What is independent activity events in probability? That is, two events A and B of an experiment are said to be independent if occurrence of A cannot influence the happening of the event B. That is, event are said to be independent if the occurrence or non-occurrence of one does not affect the probability of the occurrence or non-occurrence of the other. Example, suppose a bag contains 6 white and 3 red balls. 2 balls are drawn from the bag, one after the other. Consider the events. A is equal to drawing a white ball in the first event and B is the drawing a red ball in the second draw. If the ball drawn is the first draw, it's not replaced back in the bag, then events A and B are dependent events because P of B is increased or decreased according as the first draw results as a white or red ball. If the ball in the first draw is replaced back in the bag, then A and B are independent events because P of B remains same whether we get a white ball or a red ball in the first draw. It is evident from the above discussion that A and B are two independent events associated with a random experiment. Then P of A restricted B is equal to P of A and P of B restricted A is equal to P of B and vice versa. If A and B are independent events associated with the random experiment, then P of A intersection B is equal to P of A into P of B. That is, the probability of simultaneous occurrence of two independent events is equal to the product of their probabilities. Mutually independent events. 3 events A, B and C are said to be mutually independent if P of A intersection B is equal to P of A into P of B, P of A intersection C is equal to P of A dot into P of C, P of B intersection C is equal to P of B into P of C. Finally, P of A intersection B intersection C is equal to P of A dot into P of B into P of C. Here we use that the last formula P of A intersection B intersection C is equal to P of A, P of B, P of C. Now we convert this problem into our mathematical notation. That is, P of A is equal to probability of A hitting the target. That is 4 by 5. P of B is probability of B hitting the target 3 by 4. P of C, probability of C hitting the target 4 by 5. Now the formula is probability of all hit is equal to P of A into P of B into P of C. Therefore 4 by 5 into 3 by 4 into 2 by 3. Finally we get the answer 2 by 5. Okay. Thank you.